All right, everyone. At this time, I'm going to go ahead and get started. Again, my name is Caroline Wright. I'm the marketing manager here for Convergence Consulting Group. I'm going to kick things off with a quick introduction before we hand it over to Ahmed for our technical demonstrations today. Here's a quick agenda of what we're going to cover. I'm going to walk us through an introduction of who we are and then go through what role weather plays in our lives and go through some effective business cases that we will help demonstrate today through just one example in restaurant services. We'll go through a goal of a specific case study using restaurant reservations to incorporate weather data for forecasting customer behavior and customer spend. Ahmed will walk through 3 demonstrations of leveraging Python technology and IBM Cognos analytics for predicting these outcomes. And then we'll go through some interesting results. Can't have a webinar without giving you a little bit of information about our company. We're Convergence Consulting Group. We're headquartered here out of Tampa Bay, and we are a data and analytics consulting firm. As you can see from the screen, we're vendor agnostic consultancy. Today, like I said, we're going to be using Python and IBM Cognos analytics, but there's a lot of different tools that you can utilize to do any of these things that we're showing today. We can help you with a lot of those. We specialize in advanced analytics, strategy and management, and information management. My co-speaker today is Ahmed Sherif. He's a data scientist here for Convergence Consulting Group. He's been here for just over a year now. He has a master's in predictive analytics from Northwestern University. He specializes here in data warehouse modeling, data analytics, and really predictive analytics for our customers. He's a popular speaker. You may have seen him at the most recent SAP Insider Reporting and Analytics Conference in Orlando, and he's spoken at plenty of ASEG user group meetings. You can follow him on Twitter at @Ahmed or connect with him on LinkedIn. We'll provide all of that information at the end of the webinar as well. So let's dive right into it. This one's kind of a funny picture here, but we all know we used to not at all be able to rely on the weather guy. You used to pull up your phone and, maybe there's a 50-50 chance they're correct. Well, that's no longer the case, especially with the weather company being purchased by IBM. There's a lot of reliable data we can get 10, even more so, days out of what's going to happen in our environment. And a lot of that can really affect what customers do. Think about it from an individual perspective. Are you going to go to the movies with your kids because it's raining? Are you going to go to the store because it's raining? Maybe you're going to actually be more likely to purchase things online because it's raining outside. Is there severe weather coming? Do you need to maybe shut down your offices? Is that going to affect closing business? What about fulfilling your shipments? What if you are trying to ship something to customers? Is it going to get there on time? Even moving something like heavy machinery, do you need to reroute it? How can weather really affect your business? I hope that throughout this webinar you're starting to think about those things, and even as we're walking through this one example, think of how you might be able to use weather data in your own company and take some of the things you're seeing today and go ahead and practice it yourself. Today, like I said, we're going to be focusing on one specific use case, just to walk you through an actual demonstration of how you can utilize weather data specifically. Today, we're going to ask, how likely are you to cancel your fine dining restaurant reservation if it starts to rain? Whether it's your anniversary or it's just a Friday night, if you make a reservation at, Chuck's Steakhouse and it starts pouring 10 minutes before you're about to walk out the house, how likely are you going to actually go to that restaurant? Maybe it depends on how much it's raining. Maybe it depends on the shoes you're wearing. But it definitely has an impact. How much, though? Ahmed's going to find out for us today. Today we're going to use reservation data. So actually 5,000 reservation requests that we are going to analyze at a fine dining restaurant in multiple restaurants across the U.S. The objective is we want to estimate the percentage of reservations that get canceled depending on the forecast that day or really that hour. So how far in advance can we look and say, okay, if the weather's bad, what percentage of cancellations are going to come in our reservations? And how can we maybe adjust as an individual restaurant to maybe taking more walk-ins or understaffing or making even inventory decisions based on that weather prediction? Today in the demonstration, Ahmed's going to utilize 2 different technologies. Python, which is an open source technology that many of you are probably aware of. Is used for data prep, data analysis, and predictive modeling. And they're also going to utilize IBM Cognos analytics for the visualization piece. Now, this is something, IBM Cognos Analytics is a fantastic tool, but you could use this in any of the analytics tools that you have in-house. If you have MicroStrategy, SAP, Tableau, this is something that you can utilize with really any technology that you are using. You don't need to technically go out and buy IBM Cognos Analytics if you want to be successful, but it's definitely a great product. And just a funny little note here, if you're not familiar with pandas, that's something that Ahmed will reference multiple times today. It's actually an open source library that's part of the Python programming. It allows easy-to-use data structures and data analysis tools right out of the box. It's a fast data frame for data manipulation and data merging. As you can see here, this is what we are about to walk through as I hand it over to Ahmed. He's about ready to demonstrate now. We have 5,000 reservations from this restaurant, again, from all over the country. And then we're also going to merge that with weather data from those reservation dates and then see if we can predict the cancellation rate. Now I'm going to hand it over to Ahmed to start the demo.
I went ahead and recorded all of the demos ahead of time because if something can go wrong with a webinar demo, it probably will. So here is what we have right now is the spreadsheet that has all of the reservation data. What you can see here is there's a bunch of columns, a lot of stuff in terms of how many people were on the reservation count, what city the reservation was in, what menu tier was made. These are all things that are specific to the restaurant. And I'm going to go ahead and just show you here. At the beginning, you have the timestamp for when the reservation was made and the zip code. These two things are of the most important for us and most importance for us in terms of tying it to the weather data. So I'm just giving you a preview of what this data looks like. What we're going to do next is we're going to open up a Python script, and I'm using a Jupyter Notebook. Jupyter Notebook are very common ways to write Python in. The nice thing about them, as you will see, is you can execute the rows line by line. And so what I'm going to go through here is just a simple execution of row by row to pull in the data. And I'm calling out the location of the file, that's the CSV file holding the reservations, and I'm going to assign it to a data frame. And then here, once it gets pulled in, I'm going to preview the data. So here you now see the same structure that was in the spreadsheet inside of the code. Now it looks pretty much the same way, and that's what we call a data frame. Now I'm going to go through a little bit of formatting where I'm going to pull in some date time formatting to make sure the data looks, the date looks comfortable for it to be consumed. So I have it in a year, month, day format. Did a little bit of more formatting to strip out the zip code. Something here I want you just to kind of focus in on. I went ahead and took the data set. We had types of source reservations. So the reservations were made either using the phone, using the web, or a walk-in. As far as a walk-in is concerned, it's not technically a reservation, so it can't be canceled. If they don't know that you're coming, they can't know that you're going to cancel. So I'm only filtering in data for phone call reservations and web reservations, and that's what this line here is doing. As we continue, just doing a little bit of formatting for the zip code. I only want the first 5 digits of the zip code so that I can tie that to the weather. Do a little bit of more filtering, and then here I'm going to specify I only want certain restaurants in certain cities. Once that is done, I'm going to run this large API script here. And really I don't want to get too much into the scripting Python to tell you what I did with each step. I just want to bring your attention to this URL here, which is an api.weather.com link. And as you can see, what it's asking for is 3 things. The zip code for the different city, the start date of the reservation, and the end date of the reservation. So we're doing a loop, basically, where we're running this every time, and then we're pushing in these values, and we're telling the API, tell us what the weather was for this time. And what we're going to get is what the weather feels like, what the wind speed is, what the visibility, the gust, the pressure, and the conditions. And we're going to go ahead and run that. And once we run that, it happened quickly, so you really can't see anything, but I'm going to show you what the outcome is. And so now, what you get here is the same data we had before, and we've appended several columns towards the end which tell us what the weather was. So for this city with this zip code, at that time, the weather was between 97 and 98 degrees with a wind speed of 7 to 9. The visibility was a 10, which means I guess you can see pretty clearly on the highway. There wasn't anything for gust, so that came back as a null. And then the weather pressure was somewhere between 29.25 and 29.24. And for all these times, the weather was fair, which means everything was normal, nothing really to be worried about in terms of the weather. We then are going to take that and we're going to output that to a CSV file. So I just want to show you, we saw how it looks like inside of the notebook for Python, but if you export it out to a CSV file or a spreadsheet, you can see that the same data set now is in a spreadsheet file that's very convenient to be used and can be consumed however way you would like to consume a spreadsheet with data in your environment. So that's kind of how we got from reservation data only to reservation data plus weather. So we can go ahead now and resume our demo or continue with our presentation. So that was our demo for the pandas. So we have our data now. It's in a data frame. It looks familiar in terms of formatting that's useful to use. Now we want to apply some data analysis on that data to get an idea of how that data combined looks together with the weather and the reservations combined. So what Python has is that it gives you the ability to create crosstabs pretty quickly, similar to the way you would with a PowerPoint presentation or a pivot table in Excel. So what Python has, and Pandas has a function called .crosstab, which gives you the ability to add two different columns and do a count on them. And so what I basically wanted to do is I wanted to see of the 5,000 cancellations, how they were broken up. So we can see here that for the 5,000, 337 were no-shows, which is basically they called to make a reservation, but they never called to cancel. Completed means they fulfilled their reservation, and 785 actually took the time to call in and say that they wanted to cancel their reservation. So we're looking at about 1,000 reservations that were canceled or no-showed out of 5,000. So you're looking at about 20%. We're going to take that further now and do a crosstab on the status, but this time we're going to look at and break it out by weather conditions. So you can see the API gave us a lot of information in terms of the different weather conditions we have. In fact, sometimes you can say it's a little bit too much information because I don't know what the difference between cloudy versus cloudy/windy is. To me, it's the same thing, but it's nice that it gives you that level of data to break out. And so you can see you have cloudy, windy, fair, foggy, hazy, light rain with thunder. I mean, you can get really granular in terms of the level of detail you want to get with the weather during the time that you made that reservation. So that's sort of a crosstab of weather versus status. So let's look at the status versus the actual city. So we looked at a certain number of cities here, and we want to see the breakout of how they were affecting the different cities for the times that we had. And so we have here the same thing with the canceled, the completed, and no-show for the different cities all the way from Austin to Seattle, Tampa. So this is very, this was done with a very quick Python script. You just type it in, you do a crosstab, and you're able to get your data formatted in a way that's very easy to use. And people who use Excel, they're very commonly comfortable using pivot tables. So this is basically the exact same thing. I wanted to go ahead and simplify some of the data since we have so much granularity. For the purposes of building our predictive model, though, I really wanted to make it as simple as possible so we can just kind of dive down into the nitty-gritty details. And what that means is that for the status, as far as we're concerned, there really isn't anything different between a canceled reservation and a no-show. So we're going to just group those into canceled together. Otherwise, everything else is going to be completed. As far as the weather is concerned, we're going to say that if the weather was fair that day, then it was nice weather, meaning the weather did not have an effect good or bad on the outcome. Everything other than fair, we're going to lump as poor weather. And so we created 2 new columns to our data frame here. And this is the logic that we use to build the good and bad weather indicators, as well as the cancellation. So if anything is, it says here, if anything is canceled or a no-show, I want to give it a value of 1. And that's going to be our indicator. Other than that, if it was completed, we're going to give it a value of 0. And you'll understand why I'm doing a 1 versus 0 when we look at our model that we're going to do for our analysis. So once I simplified the data, now I look back and I see, okay, the data looks a little bit cleaner now. I've kind of grouped it up. I have my cancellations as a 1 or 0, 1 being canceled, 0 being it was completed. And then I have the nice weather versus poor weather breakdown. This is a little bit easier to read versus the long crosstab that we had initially. Additionally, if I wanted to visualize this, I could take the same crosstab I had up here, and all I would do is just add a dot plot equal kind equals bar, and I can create a quick bar chart just to kind of see how the data looks from a visual perspective. Python, in addition to having nice data analysis libraries, it has a lot of powerful visualization libraries that can be done on the fly just to get a sense of how your data is appearing from a visual perspective. Never hurts to have both ways available to users who might be more visually inclined versus a spreadsheet or pivot table inclined. So we've got our data set up in a way that's what I would call predictive model friendly. We want to go ahead and build a predictive model. More often than not, people who are new to predictive analytics might get kind of bogged down in terms of the different models that can be out there. There are tons of models, and there are many different ways to build the same model, and it can get kind of difficult to get started. I found that really there are maybe a handful of models that are used 75 to 80% of the time, and if you can get comfortable with them, you would make your life a lot easier. One of those models is called a logistical regression model, and I really like using logistical regression models whenever you're dealing with a binary outcome. What do I mean by that? Whenever you're dealing with something where you have 1 or 2 outcomes, and you want to know one of them or not, that's really what a probability is. In a sense, a probability is anything between 0 and 1. But what we do is we say if something is greater than 50%, we're going to say it's a 1. If it's less than 50%, we're going to say it's a 0. And what that 0 or 1 are basically dependent upon you. So if somebody passes an exam, it's a pass or fail test. If you're tossing a coin several times, then 50% of the time it could be a heads or tails. And for our purposes, whether the reservation is canceled or reservation is kept is a probability between 0 and 1. Anything above 0.5, we're going to say they're going to get canceled. Anything less than 0.5, we're going to say it's going to be kept. And so really, it all depends on what is important to you to decide how you want to measure. If only 10% is really what you're trying to find, then really 10% becomes your success or failure ratio in terms of your predictive model. Some of the assumptions that I want us to keep in mind when we're building the model is this is not, at the bottom here I say all models are wrong, but some are useful. And I mean that by saying there's always going to be a better model out there. So you want to just keep in mind that a good model is a model that can be adjusted and allow for more parameters to come in here. We're only using 5,000 rows of data. Maybe if we had more than 5,000 rows or we had data that is representative of different times of the year, we would have a better model that can give us an outcome. Now, keep in mind, we're also looking at the data being grouped as either good or bad or good or poor weather. We're not going to look at all the levels of granularities. We're not looking at the different conditions in terms of wind gust or wind visibility. We're just focusing on what the weather was either fair or not fair. And for the purposes of this demo, we're not focusing on other than non-related reservation, the non-weather related reservation predictors, such as what was the head count of the people making the reservation, how far in advance did they make the reservation. All of these are probably good predictors in terms of whether or not the reservation would be canceled. But because we want to just focus on the weather, we excluded them from the purposes of this demo. So those are just some things to keep in mind. But before we do that, we have a couple of questions that we wanted to ask of you guys. So I will go ahead and hand those over to Caroline, who will take care of them.
Thanks so much. I'll go ahead and launch those now. Our first question is, do you currently have a predictive analytics platform in your data warehouse? As you guys can see, it's pretty split between if you have a predictive analytics platform or if you don't. But it seems like a small percent of you guys aren't currently utilizing it. So maybe, hopefully for you, you can take some of the things you're seeing today from Ahmed and utilize them yourself. Let me go ahead and launch our next poll. So how likely are you to use an open source predictive technology such as Python or R? As you can see, 42% said you are somewhat likely and 70% said very likely. But we still have a quarter of you guys saying that you're very unlikely to do this. So I'll go ahead and pass it back over to Ahmed, but thank you so much for sharing with us.
Thank you, Caroline, and thank you all for sharing your responses with that. Build our predictive model. So we have our second demo. So once again, we're using our Jupyter Notebook to build our Python model. And what I'm going to take you guys is through step-by-step kind of what we're doing. First thing we're going to be doing, again, is we're going to be loading our data set now that we built in the previous example where we had our reservation and our weather data joined up into one spreadsheet. And I'm going to go ahead and read that now and input it into the Python script. And as you can see now, we have our data here. It looks just like what would be in a spreadsheet. We're going to go ahead and run. I'm going to make sure that I have the restaurants that I want, and it looks like those are the ones that came through. Everything looks good. Now I'm going to show you kind of how I built those data analysis crosstabs that we showed you in the spreadsheet. So that was the first one. This is the next one here where we had our cancellations by the weather of the day. Now we have basically the count to give us sort of an idea of what percentage we should be expecting for the weather being good versus, or completed versus not completed. Doing a little bit of data munging here to get the data to look kind of the way we want it for the crosstab, where we're doing our cancellations as zeros or ones. And then we can kind of get an idea here in terms of the spreadsheet that we showed you earlier where we had our nice weather versus poor weather. And then this one here is going to do the map plot, which gives us sort of a visual representation. Now what I'm doing here is just I'm renaming the columns, and I'm going to now build my model. And as you can see here, I'm basically saying I want to know what value the cancellations have in terms of the weather status and the restaurant. So our model is saying this is our dependent variable, the cancellations. These are our two independent variables. So I'm going to go ahead and run those two right now and create two matrices. So we're building out our model. And then I'm going to show you what the columns look like here. And so it's taking each restaurant and it's taking the weather and it's building it out into a matrix. Now what I'm going to do is I'm going to take our model and run the logistic regression, and I'm going to fit it to the X and the Y variable, the X being all of our predictor, which is the restaurants and the weather, and Y being our outcome of the 0 or 1. 0 being no cancellation, 1 being yes cancellation. So now we're going to get our score, and our score says we're able to get this to a 76% accuracy, which is actually not bad. That means 76% of the time we're able to predict whether the weather can cause a cancellation to the reservation. Now what I'm going to do is I'm going to show you guys what the data frame looks like for the different predictors. So this gives us an idea of which of the restaurants and which of the weather had a positive or negative effect on the outcome of the data set. or outcome of the output of the model, which is whether the reservation occurred or not. Now I'm going to, we took our predictors now for the 10 different cancellation rates for the different cities, and we stored them in an array. And what we did here is we have, this is our positive, that there would not be a cancellation, and these are our negatives, that there would be a cancellation based on the weather. And they're stored in arrays. So what I did is a little bit of data management, and I tied these to the actual reservation name for the hotel, for the restaurant, excuse me. So each now restaurant has a cancellation rate for whether or not it hit a whether or not its reservation was canceled based on the inclement weather during that day. So as you can see, based on the different cities, the variation is higher basically by a couple of percentage points. Houston being the highest, and looks like Dallas is the lowest. So we can go ahead now and upload these results into Cognos Analytics and visualize them further. So what we did here is we just want to do a quick and dirty visualization where we exported our table, which is here, into a spreadsheet. And then in that spreadsheet, we can then visualize how likely you are to find a cancellation in a specific city based on the rain. And what I went here is I uploaded the data, and I was able to quickly do a very simple visualization inside of Cognos and get a cancellation chart, bar chart build up from descending order very quickly. So let's go ahead and show you guys how I did that. So what we have here is a simple, we're going to log into Cognos. And once we log in, we already have the spreadsheet uploaded. We're going to create a dashboard. The dashboard, we're just going to make it very simple here. We're going to do a free-form single page. And then we're going to pull in our content. And the content here, we're going to open our file. We're going to pull in our data. And as you can see, we only have two columns here, which is the restaurant name and the cancellation rate. And then we're just going to go into the visualization charts, and we're just going to pull in a very simple, straightforward bar chart. And it takes a minute to load because this is all web-based. And what we have now is we have our axes and our value that we want to use. So we're going to our restaurant name, and we're going to add that to the axis label. This is basically a drag and drop. And then we're going to do the same thing for the cancellation. It's a measure, so it's going to go into the value section of the dashboard. And now we have our quick and dirty little visualization here. I'm going to do a little bit of formatting. I'm going to sort it by descending order, so we can kind of get an idea from highest to lowest. And as you can see, Houston is our highest, Dallas is our lowest, and we'll make it a little bigger. And we'll go ahead and maybe give it a title name. Or you can just go in there and edit the title. Once it becomes available on Cognos Analytics, it can easily be shared by anybody within your company using a link. And you're basically good to go at that point. So very straightforward. We started out with data set that had a high level of reservation data without any real weather behind it in terms of aggregation, and we were able to say, okay, based on those results, how likely are, if everything being equal, how likely are these different cities willing be seeing reservation cancellations in the different markets if the weather was to be inclement in some way. Now, there are ways you can make the model more responsive. You can, if you have data available during certain times of the year, a reservation made in January may have a different effect to the cancellation rate versus a reservation made in June. All that has to do with having a wider data set, more ability to factor in exceptions, or factor in variations, and so on. But all these can be helpful to customers. So, for example, restaurants in Dallas versus Houston, a restaurant manager may more likely make adjustments during that day for somebody who's coming into the restaurant making a reservation versus somebody in Dallas, because they're less likely to see inclement weather have an effect on their cancellation rates. So these are things that can be very powerful to the management team of a company or of an organization, just to make adjustments, knowing things changing that day or changing days ahead of time, as we're able to now just pull up our phones and see what the forecast will be in on a Thursday if we're on a Tuesday at 4 p.m. for example. And therefore you can either increase staff, decrease staff, accept more reservations than you normally would. Some of the resources that I used here for the presentation, I just wanted to give you an idea of where you can find more information. To learn more about pandas in general and Python, Pandas has a really good website, pandas.pydata.org, where you can kind of understand where Pandas started initially and how it became a popular library for Python. To understand logistical regression analysis, Wikipedia has a really good sort of a example of how a logistical regression can differ from a typical linear regression where you're trying to understand a straight line and get more familiar with the purposes and where you would use a logistical regression versus using a more traditional linear regression. Additionally, Cognos Analytics, there is a great 45 video playlist tutorial on YouTube that is very helpful for the latest version of Cognos that you can find online. As far as just finding general weather data, you can go to the National Oceanic and Atmospheric Administration website, NOAA.gov, and you can find historical weather data that you can pull in. As far as getting the specific weather API scraper, that came from weather.com, and that was that script we built in Python where we were able to input in certain parameters for the zip code, the start and the end date, to again retrieve the measurements for the different weather forecasts. And there are a lot of forecasts you can get in terms of weather. We restricted it to 6 different types, but there's even more than that. So something to, you can really get into the weeds and understanding all the different factors that may come into play when understanding human behavior. At this point, I will open it up to Q&A and hand it back to Caroline.
Thanks, Ahmed. We did have 2 questions come in so far. If anyone else has one, feel free to ask it now. We do have a couple minutes. The first question is definitely a good one because it relates right back to our survey. So is there a way you can run this analysis without using an open source application like R or Python? We did see that about 40% of the attendees today are not interested in using tools such as those.
Yes, there are many different ways that you can use tools that are not necessarily open source. More and more of the more enterprise platforms for BI are leveraging predictive analytics in terms and their platform, and they're sort of making it more of an automated feature. So it's not something that's necessarily it's proprietary. So for example, SAS has its tool that's very commonly known. IBM has a tool or relationship with SPSS that's also available. SAP has a tool called Predictive Analytics 3.0, which is sort of a hybrid of its own tool plus another tool that they purchased from a company called KXEN that does more automated analytics. So there are ways to do these now within your business intelligence platform to not have to leverage an open source programming language, especially if you don't have programmers within your BI department. So there are platforms that do leverage that. The downside to those, I would say, is you have less control in terms of the proprietary knowledge that they're building the models for. So, for example, SAS has a very popular model, predictive model algorithm, but it's proprietary and it's closed source. So you don't necessarily know how they're building their algorithm. You are sort of at their mercy. Now, they have a good reputation. At the same time, though, it's not free. So, but if you do have one already, it's great. Something I will note with Python and especially with R is that they are now being leveraged more and more in terms of the current BI platforms. So while Microsoft, for example, Power BI does not necessarily have a predictive tool in it, it does leverage R as an extension so that you can bring in R algorithms into your tool, and then the work that you've done with R can be brought in and visualized inside of Power BI. Tableau does that as well. So this is something that's picking up popularity with the traditional BI platforms or data discovery tools that we are used to dealing with. But that's a very good question.
Great, thank you, Ahmed. And if anyone has specific technology questions out there, as we did mention earlier on this webinar, CCG is a vendor-agnostic firm, so you can simply email us and ask, if you can do this with SPSS, and we can provide guidance on that. The second and final question, Ahmed, is if you had to write all of this code from scratch?
Did I have to write all of this code from scratch? The answer is no. I had to write a lot of this code, but there are some things that I was able to get online without having to start from scratch. So, for example, all of the data preparation, building the crosstabs, manipulating the data, that was all I had to do. I had to do on my own. But, for example, the script to run the API, that was made available to me. Additionally, there were scripts that I used that for doing the looping of the script to produce the PDF file and join. That was something I had found online. And a lot of the nice thing about using Python and R is because they are open source, a lot of people have done the heavy lifting ahead of time. So you don't necessarily have to start from scratch and reinvent the wheel. The chances are pretty good that somebody has already run into an issue that you are looking to solve, and they've probably come up with some solution or proposed something online that you can take, tweak, and then make it work for you. So while I didn't just copy, or I didn't find something that worked online and just applied it to me without doing any work, I had to go in there and manipulate it and change some things so that it's appropriate to what I need. I was able to find a lot of this stuff online to get a good starting point so that I wasn't starting from scratch. And to be honest with you, everything that I've done, whether it's in the predictive analytics space or just the general BI space, I never really started it from scratch. I would find a good blog or a good website that had some information that I was looking at, and then from there I was able to build on that and enhance what I needed. The only thing I would say is that if you're using these codes, definitely share within the community and post your results back to the users so they understand that what they did helped you. And then when you share your results, you're ultimately going to be helping somebody else who will be looking to maybe pick up from where you left off. That's why the Python and the R communities are very popular, is that there's a very open sharing environment where people contribute a lot, and so they get a lot back. Again, that's sort of the difference between more of an open source environment and a closed source environment in general, is that you just have that willingness to share, and you don't have that proprietary mindset with some of the relationships. It used to be harder to do this stuff with Python and R, and that's why tools like SAS and SPSS were so popular. Now they're finding that the stuff that you can only do with SAS, you're now able to see you can do with these open source technologies. But that's a very good question as well. Definitely, definitely, a lot of this you can find a good starting point online. Okay, if those are all the questions, I want to thank you all for attending. I have here at the bottom just an email address. It's very small. If you can see it, it's asharif@ccgbi.com. All the demos, the video demos as well as the scripts are available. Just send me an email and I will forward you a Dropbox link to download the videos as well as the scripts, and you can start playing around with it yourself. Also check out our website, ccgbi.com. We just launched it, a new updated version today that's live. It's looks really cool, so I definitely recommend you check it out. Also, feel free to email any remaining questions to Caroline at cwright@ccgbi.com if your question was not answered during the webinar today, but we'll definitely get to you outside of the webinar. If nothing else, thank you very much again and have a great rest of your day.